Now, in this video, we will going to take up one more problem on the projections of lines, the problem number 78. We are going to try to analyze this problem by using 3D drawing and also how to solve this problem by using the sketchbook. First, the top view of a 75 mm long line measures 65 mm while the front view is 50 mm. Its one end capital A is in horizontal plane and 12 mm in front of VP. Draw the projections of capital AB and determine its inclinations with HP and VP. So as we see, one end A is in HP. So obviously when you look from the front view, that image will going to fall on the vertical plane. So you're going to get it as A dash. And 12 mm in front of VP. So in front of VP, when you look from the top view, we can see the distance 12 mm in front of VP. So, and you mark this point. The image, when you project it, the image will going to fall on HP, and you mark this as small a, and this will going to be the capital A. Then he says the top view of a 75 mm long line, capital AB, measure 65. So first what we need to do is we need to consider, as he has given the front view, top view, and its inclination is not given, and only the true length is given. Now, the concept is if the front view line is parallel, correspondingly the top view will go to be in the true length. So applying by that concept, you make A dash B1 dash, you make that line parallel to HP because A dash is in HP, so obviously the B1 dash should also be on HP. So when you from A dash you measure the distance of 50 mm, make that front view line parallel. So that means NDA is in HP, B1 dash is also in HP. Correspondingly its top view will going to be in the true length. So from B1 dash you draw a vertical projector to the top view. Then with A as center, taking the radius of 75, cut it on this end projector line. So you mark this point as B1. So you draw a locus of B in the top view. So now you got the true length. Join A and B1 with little bit thicker than the XY line. So you will going to get the true length in the horizontal plane. So you got the locus of B in the top view. Now similarly, I want to find out the true length in the front view. So to do that, so we need to consider the locus of B in the front view. So you take the top view distance. The top view distance is 65. From A, you measure a distance of 65 mm parallel to the XY line in the top view. That means end A is in front of VP by 12 mm and the top end B2 is also in front of VP by 12 mm. The distance between A and B2 should be equal to 65. So from A, you measure the distance of 65 mm and you mark this point as B2. Then, now the line is parallel to VP. So correspondingly, in the top view, in the front view, you will going to get the true length. So from B2, you draw a vertical projector here. And again from here, you draw a vertical projector to the front view. Then you take the distance of 75 with A dash as center, cut an arc on that end projector line. So you will going to get the B2 dash. Then draw the locus of dash dot line in the front view. Then you mark this as the locus of B and you mark this as B2 dash and join between A dash B2 dash with little bit thicker than the XY line. Now we got the true length in the front view and also the locus of B in the front view. As we got the locus of B in the front view, so with A dash as center, taking the radius of A dash B1 dash, you draw an arc such that the B1 dash, which was originally on HP, you made above HP by this distance. So that it will going to cut this B dash here, then join A dash B dash with a dark line. So you got the front view. Once you got the front view, then we need to get the top view. So to get the top view with A as center, taking the radius of AB2, draw an arc such that it will going to cut the locus of B in the top view. So you mark this point as B, then join A to B with a dark line so that you will going to get the top view distance. Then draw a vertical projector from B and also draw a horizontal projector from here. Both will going to intersect at this point. So you mark this point as capital B, then join A to B. So this is the actual line which you are going to get in the space. So when you take from the front view, so that will be projected here. So this will going to be the front view point. And when you project it from the top view, so this will go the image what you will going to get here is the small AB. So actually when you are this is by justification, Once you get this, when you rotate it in space, you will going to get AB1, and when you are rotating like this, you will going to get AB2. So that is what we have shown here in the horizontal plane, and this is what we have shown in the vertical plane. So this is how we can analyze this problem in 3 dimension. Then as we see here, so when you make the front view line parallel, so you will going to get the corresponding line will going to be in the true length. So you will going to get B dash, as that is B1. So you got the locus of B in the top view. So once you get the locus of B in the top view, so here you can see, make the front view line parallel. So correspondingly in the top view, we're going to get the true length. So from A, you take the distance of 75 and cut an arc. So you will going to get the locus of B in the top view. But now we haven't yet got the locus of B in the front view. So that is for to have the justification. So that is the reason why we have shown this as the reference. Now when you go for the top view, so when you want to have the true length in the front view, so you make the top view line parallel. So that means that is AB2 is the line which is made parallel. So correspondingly, you are going to get the true length in the front view. So you are going to get the locus of B in the front view. So that is how we have shown here. So how we can explain here with A as center. Now you take AB2, you make it parallel. So that means this AB, the length of AB2 will be equal to 65. That is both A and B2 are in front of VB by 12 mm. And draw a vertical projector from B2 to the front view, and you take the distance of 75 with A dash as center, cut an arc on this end projector, so that you will going to get the B2 dash, which will going to be the locus of B in the front view. So once you got this, now we know that the front view is 50, so which was originally here, which you have been rotating, so that you will going to get this B dash. So and also the top view, you just revert it back, so that you will going to get the top view. So this is how you will be able to analyze the problem in 3D and as well as in the stepwise. Now we will going to try to solve this problem by using the sketchbook. First we will going to draw the XY line, and you mark VP and HP. So from consider any point from A dash, because A is in HP. So consider any point on XY line, you mark this as A dash and this as capital A. And from A dash you draw a vertical projector below XY line, and you measure 12 mm. With A dash as center, mark this point small a on this vertical projector. You mark this as A, and here this as capital A. So you make the front view line parallel. From A dash, you measure the distance of 50 on the XY line, and you mark this point as B1 dash. Through B1 dash, you draw a vertical projector to the top view, and then by using the compass, you measure the distance of 75 with A as center, cut an arc on this end projector line, so that you will going to get B1. Once you get this B1, so this will going to be, because this is the true length, you mark this as capital B. Then through B1, draw a horizontal dash dot line. So you mark this as the locus of B in the top view. Similarly, from A, you measure the distance of 65 and mark on this horizontal line of A, and you mark this point as B2. That means A is in front of EP by 12 mm. B2 is also in front of EP by 12 mm. Now the line is parallel to VP. Since the line is parallel to VP, so you are getting the true length in VP. So from B2, you draw a vertical projector to the front view. With A dash as center, take the radius of 75 by using the compass, cut an arc on this end projector line, and you mark this point as B2 dash. As 75 mm long line is the capital AB, you mark this as capital B. Then join A dash B2 dash with little bit thicker than the XY line, and draw a horizontal dash dot line, and you mark this as the locus of B. So now with A dash as center, by using the compass, with A dash B1 dash is the radius, you draw an arc from B1 dash such that it will going to cut the locus of B in the front view, and you mark this point as B dash and join A dash B dash with a dot line, so that becomes the front view. Similarly, by using the compass with A as center, taking the radius of AB2, draw an arc such that it will going to cut the locus of B in the top view, and you mark this point as small b, then join A to B with a dark line. So you will going to get the top view as both B dash and B, when you join, both will going to lie on the same line. So show the dimensions and mark this as theta and phi. These are the true inclination with respect to all HP and VP. and alpha and beta are the true apparent inclination with respect to HP, and this is with respect to VP. So by using the protractor, you measure the angle of theta, which will be 30 degrees, and measure the angle alpha, which will be 48 degrees. And similarly with AS center, by using the protractor, you measure an angle with respect to XY line that is parallel to this. So this line AB2, you measure the angle which will be equal to phi, which is 48 degrees, and beta, which will be 59 degrees. So when you are doing it in computer, alpha will be equal to 48.45 degrees, beta will be equal to 59.32 degrees, theta will be equal to 29.93 degrees, and phi will be equal to 48.19 degrees. So this is how you will be able to complete the drawing by using the sketchbook. Thank you.